Okay, this video is about graphing quadratic functions. Now remember, it's a quadratic because its highest exponent is a 2. Do you remember when we did linear equations, when I would graph something like y equals mx plus b? These had exponents of 1. And that's why when we graphed it, it was a straight line. But a quadratic function, its highest exponent is a 2. And when we graph a quadratic, we're going to get a parabola. It might look like this, or it might look like this, but it's a curve. And it's a symmetrical curve, which means it has a middle line that divides it in half. All points on either side are mirror images, and there is a point on the line of symmetry that's called the vertex, and that's where the parabola changes direction. And that is also going to be either the highest point or the maximum point on the parabola, or the lowest point, the minimum point on the parabola. So this line that cuts the parabola in half is called the line. Sometimes it's called the axis of symmetry. And this point that's either the maximum or minimum point where the parabola changes direction is called the vertex. This point is always on the line of symmetry because the line of symmetry cuts your parabola in half, and the vertex is where it changes direction. So the vertex will always be on the line of symmetry. Where this parabola touches the x-axis is called its solutions, or its roots, or its x-intercepts, or its zeros. And where it touches the y-axis is called its y-intercept. So let's check this out. If I ask you to graph this equation right here, or this function, this is a quadratic equation because its highest exponent is a 2, but it's not in standard form. Standard form looks like this. When a quadratic equation is in standard form, the y is on one side of the equation all by itself. So what I have to do in this particular equation before I start is put it in standard form. So I need to get y isolated, and I need it to be a positive y. So here's what we're going to do. We're going to take this quadratic equation. Remember, it's a balance just like any other equation that we worked on in algebra. And if I want this y alone, that means I have to get rid of this and this and this. So the way I can get rid of 1 negative x squared is to add 1 positive x squared. And if I add it to both sides of the equation, that's a legal move because it keeps everything balanced. So I can cancel these out and I have this. But while I'm at it, if I want to get rid of negative 6x, all I have to do is add 6x. But if I do it to this side, I better do it to this side to maintain my balance. And then I need to get rid of this negative 8. Well, the opposite of negative 8 is positive 8. If I do it to this side, I better do it to this side. So let's see what we've got. I have y. 1 negative x squared and 1 positive x squared cancel each other out. 6 negative x's and 6 positive x's cancel each other out. 8 negatives and 8 positives cancel each other out. So I'm left with y alone on the left side of my equation, and it's a positive y. And then over here, I added a 1x squared and a 6x and an 8. I am now in standard form. Y equals ax squared plus bx plus c. So now I need to identify my a, b, and c values. Well, a is the coefficient of x squared. 1, in this case, is the coefficient of x squared, so a equals 1. b is the coefficient of x. In this case, b is 6. And c is the constant. In this case, c is 8. So I have my a, b, and c values. Now, if I'm going to graph this equation, I want to know its axis or line of symmetry, because that's going to be the very center line of my parabola. So the way I do that, the way I find the axis of symmetry, is to use the formula x equals negative b over 2a. So x equals negative b. Well, b is positive 6. So what I'm going to do is take that positive 6 and I'm going to make it negative. So I'm going to have negative 6 over 2 times a. A is 1, so that's 2 times 1. So I have negative 6 over 2. And if I simplify that, I get negative 3. So x equals negative 3 is my line or my axis of symmetry. I'll give you a chance to look at that because I think part of it was hidden. We found a, b, and c. We used this formula for the axis of symmetry. B is 6. I need to make b negative, so I put negative 6 in the denominator. 2 times a is 1. 2 times 1 is 2. When you simplify this, you get negative 3. X equals negative 3. So I'm going to go to my graph, and I'm going to find negative 3 on my x-axis, which is right here. Here's the origin, negative 1, 2, 3, and I'm going to make my axis of symmetry on that line. Now I know where the middle of my parabola is, so all my points are going to be mirror images on this side and on this side of the axis of symmetry, because it's symmetric. Okay, now let's take a look at our equation in standard form right here. And I notice that my a value is positive. That tells me my parabola is going to open up like this. My parabola is going to open up. So here's my axis of symmetry. If my parabola is going to open up, maybe it's going to open up like this, or maybe it's going to open up like this, or maybe it's going to open up like this, or maybe it's going to be a big wide parabola. The point is, where is it going to change direction? Up here somewhere, up here, here, here. I need to find the point where my parabola is going to come to the axis of symmetry, change direction, and head back up again. So that point is called the vertex. Well, it's going to be somewhere on this line. And the equation of this line, this is my axis of symmetry, and the equation of that line is x equals negative 3. Well, then the x value of my vertex is going to be negative 3, isn't it? Because it's going to be somewhere on that line. So I'm going to make a function table, and I'm going to make x equal to negative 3, because I want this point to be on this line. So I'm going to write my equation into my function table in standard form, and I'm going to plug in negative 3 for x to find out what y is. So y is going to be 1 times x is negative 3. I'm going to take negative 3 squared plus 6 times x is negative 3 plus 8. Now remember, order of operations. Look, I have multiplication and exponent, addition, multiplication, addition. That's a lot of different operations. Order of operations tells me I start with my parentheses. Well, look, inside my parentheses there are no operations. It's just a negative 3. There's no addition, subtraction, multiplication, or division inside the parentheses. So there's nothing I can do there or there. But my next thing is exponents. Well, here's my exponent. What's being raised to the second power? Negative 3 is. So I have to take negative 3 and square it. That means negative 3 times negative 3, which is positive 9, and then I'm going to multiply that by 1, and then 6 times negative 3 is negative 18, and then bring down my positive 8. So this is 9 minus 18 plus 8. Let's see, I have 17 positives and 18 negatives. I have one extra negative, so I just found my vertex. By plugging in the x value of the axis of symmetry into my equation, I have determined my vertex. So this parabola is going to change direction at the point negative 3, comma, negative 1. Negative 3, comma, negative 1. And there's my vertex. So we know a lot about our parabola already. If this is the vertex and it's going to open up, if it's going to come up here and here, then I can see that it's going to cross the x-axis 2 times, which means we're going to have 2 solutions, or 2 roots, or 2 x-intercepts, or 2 zeros. That's all for that video. See you next time.